Chapter 3.4, Concavity and the Second Derivative Test, Day 1. First off, what is concavity? Concavity is defined as what's happening with the first derivative. It's how the first derivative changes. If the first derivative increases, we say it's concave up. And how that looks for the first derivative to increase is we need to curve towards the positive direction. Okay? The concave up shape looks like a cup. That's a little rhyme for you. Concave up like a cup. And you can have the whole cup, you can have either half of the cup. So your graph when you're concave up could look like the whole U, just the left half of the U, or the right half of the U, as in exponential graphs. For concave down, that is where the first derivative is decreasing. Concave up, first derivative increases. Concave down, first derivative decrease. And concave down looks like a frown, right? Concave down like a frown. When you have a concave down graph, you could have the whole frown, or you could have the left or right halves. And the test for concavity, what we look for is we look for the sign of the first derivative. For concave up, we look for the sign of the second derivative. For concave up, the second derivative is positive. For concave down, the second derivative is negative. So the method for finding concave up and concave down, it's very much the same as for finding increasing and decreasing, in where we'll have to find critical numbers. This time, instead of your critical numbers being where the first derivative is equal to 0, they'll be where the second derivative is equal to 0. All right, so let's try a problem. Let's find the concavity on this function. Determine the open intervals in which the graph of f of x equals 6 times the quantity x squared plus 3 to the negative 1 is concave up or down. All right, so we need to find the second derivative. We'll start with the first derivative. F prime equals, we will use the chain rule and the power rule here. Negative 6 times x squared plus 3 to the negative 2 times 2x. Let's clean that up just a little bit so I don't have such a complicated function. So that'd be negative 12x, the x squared plus 3 to the negative 2. Now we're going to have to use the product rule with the power rule and the chain rule. So we'll have f double prime equals the first function times the derivative of the second function. Using the chain rule, do negative 2 x squared plus 3 to the negative 3 times the derivative of the inside, which is 2x, plus the second function times the derivative of the first. The second function is x squared plus 3 to the negative 2, and the derivative of the first function is negative 12. All right, for this to be a little bit easier to work with, we're going to want to convert it to the fractions. We've got the negative signs. Let's convert this to the fractions. All right, so to the negative 3, that will be on the bottom. So it'll be negative 24x squared in the numerator. Check that. It'll be positive 48. 2 times 2 is 4. 4 times 12 is 48, and we got the double negative. So it'll be 4x squared, and then x squared plus 3 cubed in the denominator. The second set will be minus 12 over x squared plus 3 squared. Let's get our common denominator. So I'll multiply the second fraction by x squared plus 3, top and bottom. All right, now we got our common denominator. Our function, or our second derivative of our function, is 4x squared minus 12x squared minus 36 over x squared plus 3 cubed. We will simplify the top one step further. So that would be negative 8x squared minus 36 over x squared plus 3 cubed. All right, there's a negative sign on the top, so let's factor that out. And we'll get negative, those are both multiples of 4. So that'd be 2x squared plus 9 over x squared plus 3 cubed. And so what we're looking for is the critical numbers of the second derivative, wherever it's 0 or undefined. Well, it's a fraction. What makes a fraction 0 is what makes the top 0. Since our top, we're squaring, which makes it 0 or positive, and then adding, which makes it positive. There's nothing that makes the top 0. The bottom is something squared plus a number, so there's nothing that makes the bottom 0. So there are no critical numbers. So this is an example of a graph where it's either all concave up or all concave down. So as we go back up, we'll look at this function. It's 6 over x squared plus 3. It's all concave up or all concave down because we found no critical numbers. What we need to do then is just plug a number in and see, is the second derivative positive or negative? All right, we go to the bottom. If I plug 0 into the top, I get negative 4 times 9, which is a negative number. On the bottom, we get 3 cubed, which is positive. A negative divided by a positive is negative. So this is concave down, like a frown on all real numbers, from negative infinity to infinity. All right? And that brings us to the concept of inflection points. Our first graph had everything concave down at all numbers. There was no change in concavity. Well, as more often the case, you're going to find that some places you're concave up, some places you're concave down. Those places where it changes, those are called inflection points. An inflection point is any place where your concavity changes. Like a max or a min, you go from increasing or decreasing. An inflection point, you go from concave up to concave down, and vice versa. And you can also use the second derivative test for finding max or min. For using the second derivative test to find a minimum, what happens is your first derivative is always 0. Right? You have a function where your first derivative is 0, meaning it's not increasing or decreasing, so it's a max or a min. Well, it's a minimum if it's at the bottom of something. What has a bottom? A cup has a bottom. So if it's concave up like a cup, you have a relative min when your first derivative is 0. If it's concave down like a frown, you have a maximum if your first derivative is 0. All right? Let's use the second derivative test to find the max or min for f given here. Well, we will start by finding our critical numbers, where the first derivative is equal to 0. We will find the first derivative, which is negative 15x to the 4th plus 15x squared. We can factor out, looks like negative 15x squared. And we're left with x squared minus 1. So our critical numbers where our derivative is equal to 0 are 0, 1, and negative 1. And all we need to do here is check our second derivative to see, okay, concave up or concave down, max or min, cup or frown. All right, so we'll find our second derivative. Going back to our original part without the factored form of our first derivative, we get negative 60x cubed plus 30x. It looks like they both have a 30x in them, so I'm going to factor that out. It's easier to do a number line check if you have it in factored form, because then all you need to worry about is positive or negative. Factor out negative 30x, we're left with 2x squared minus 1. And then all we got to do is check our numbers. If x equals 0, our second derivative will be negative 30 times 0 times 2x squared minus 1, which would be negative. So it'll be a negative times a negative times 0, which anytime you multiply by 0, you get 0. So this is neither a max nor a min. If we substitute in 1 into our second derivative, if we substitute 1 into our first part, negative 30 times 1 is negative. If we substitute 1 into the second part, we got 2 times 1 squared, which is 2, minus 1 is positive. A negative times a positive is a negative. And negative is concave down like a frown. A frown has a top. So x equals 1 is a relative max. And it has a max at x equals 1. If we substitute in x equals negative 1, all right, negative 30 times negative 1 is a positive. Negative times negative is positive. 2 times x squared minus 1, x squared, negative 1 times negative 1 is a positive 1. 2 times 1 minus 1 is positive. Positive times positive is positive. So f prime of negative 1 is positive, which means it's concave up like a cup, and a cup has a bottom. So x equals negative 1 because it's concave up and a critical number. The derivative is equal to 0. This is a relative minimum. All right? So in review, the second derivative test, the second derivative helps you find concavity. Concave up like a cup, the second derivative is positive. Concave down like a frown, the second derivative is negative.